and the bars in series, the deformations are cumulative. Loads are equal in magnitude only when axial loads are applied at the extreme ends only. So the deformations are cumulative means, so you have to use the addition when finite bars are there. But when either axial load or cross-sectional dimensions are material, that the Young's modulus varies continuously cross-section to cross-section, then you have to go for the integration. That the two examples you have studied, one is the self-head example, the axial load is varying continuously. In that case, to get a change in length, you have to go for the integration. Other one example of where Young's modulus is a function of x, Young's modulus varying from cross-section to cross-section. That I can call it a theoretical case only. Practical is not possible. That is a theoretical case only. Only the examiner is want to test the knowledge of the students. In the parallel connection, loads are cumulative, deformations are equal and like in nature. Equal and like in nature. And axial load acting on any cross section can be determined by 4 ways now. One is the section method of section, MOS. Second one is the loading diagram. If ALD is closed at both the ends, sum of the horizontal force 0. I'm talking about the member horizontal. If the vertical force should be 0 means SFD should be closed at both the ends. If sigma m should be 0 means sum of the couples and sum of the moments should be 0 means BMD and TMD should be closed at both the ends. And third one is going to be the free body diagram, and the last one is the shortcut method. So I'm going to give the answers. Already you are having answers. I hope you are completed. Mr. Chinmay, so many questions I had done it now. You are asking me once again do the question number 12 and 14. What you have done in the class now? So many questions are done in the principal class. Yesterday I already done it. And you are asking me what to solve the question number 12 and 41. What is the use of doing the questions now? Yesterday when I am doing the questions, are you sleeping or what? Then so many questions are done it, and you are asking what now? Explain the question number 12 and 14, 41. It is not possible now. I am doing the so many questions in the class now, and you are asking once again explain the question number 12 and 41. What you have done in the class yesterday now? The point is what? A question number 41 at Q. Bending stress is there, axial stress is there, torsional shear stress is there. Axial and bending stress should be added. How to find out the bending stress inner fibers now? My by I or sigma B max into Y by Y max. And at Q, torsional shear stress is also not maximum. How to find out the shear stress at inner point? Means you are getting a doubt in that question. Means what now? You are not practice anything. How to find out the torsional shear stress at inner points now? At any point below the periphery. Tau is equal to tau max into small r by capital R. Axial and bending stress should be added. So sigma x equal to sigma A plus sigma B. is a hogging case. Above you are going to get a bending stress at tensile. So sigma x is equal to sigma a plus sigma b. Sigma a is given in the question. Then how to find out the bending stress? In the question, maximum bending stress given. Then how to find out the bending stress now? Sigma b max into y by y max. That's all. And how to find out the torsional shear stress at Q? Tau T max into small r by capital R. All the questions are done it, and you are asking once again now. I don't know what the new thing is there now. %, I can tell it what if anybody is not able to do the question means they are not focused, they have not practiced anything. I have already mentioned subject is completely interrelated. So much of time I spent it, I have given an example and you are asking, sir, explain question number 41. Don't go through the notes and the lecture just like a movie or a magazine now. Is a hogging case, bending stress at tensile. Axial stress given as what? How much is given now? 40. How to find out the sigma b? What the maximum bending stress given? 100. Y is what now? 30. Because diameter is given 100, radius will be, so 30. Y max is 50. So it will become as 100 megapascals. I am not leaving any of the questions now. Everything explained and you are getting a doubt means what the tau T max is given in the question now. 50 is given. Now find out the principal, can't you find out the principal stress here now? till now this year I have not done this question in the class now. All the batches, the fourth batch now. Nobody asked me to solve this question on the board now. Because they are able to do directly from the class notes. But the new thing is here now. So many times you have mentioned axial and bending stress can be added. They are in the direction of the polar axis. So in this question, what is asked now? Up to what length boring has to be done? You have to determine this x value so that what is the condition is given now. Suppose in the first case, second case, and is mentioned change in length of the bar should increase by 20%. change in length should be increased by 20%. But this is about now prismatic, same material, but it's not a pure axial. It is not, sorry, the prismatic pure axial, sorry, pure axial loading, same material, but it's not a prismatic now. It's a pure axial loading, same material, but it's not prismatic. Then you have to split into 2 bars. So this should be taken as a 1 bar, second bar, that's all. For this case, what the K value now? K is what now? Inner diameter to outer diameter. So what should I write down now? One 1.2 times the, but this should be taken as the 2 bars. It is a single bar. What the change in length of this bar now? Four PL upon this is four is the P1 this bar and this bar made of same material, therefore E is same. Which one will cancel out now? What the P1 and P2 is a pure axial loading. So which one will cancel out now? Load will cancel out. P is same. Material is also same. Pi is also same. And diameter is also same. What the outer diameter of this now? 40. What the diameter? 40. So which one will cancel out now? L1. What the length of this now? 2 minus x. Pi d square E will get cancelled out. And what the length of this bar now? X. What the 1 minus k square? K is how much is now? So simplify this one, you are going to get the x value now. In all the case, diameter here about 40. It is also 40. Its outer diameter is 40. So simplify this one, you are going to get the x value. When these are the answers, somebody is given what? Sir, initially I given 130. When these are the answers now? If you ask on the cross section, if you ask what the resultant normal stress on the cross section means 100. Resultant shear stress in the cross section means 30 at that point now. So whenever it asks at a point, so if we ask what is the resultant normal stress at point Q, resultant normal stress at point Q. So many yesterday mentioned axial bending, torsional shear, direct shear, they're all on the cross section. So you have to use this one if you ask only on the cross section. So check it, you are going to get it. Everybody is going to substitute the numericals. If you substitute the numericals, a time taking now. So whichever is what to try to write down like this now. So calculation will become simple. Everybody is going to put the Young's modulus, everybody is going to put the length, load and everything, common data. So directly will cancelled out, and this is a 1 bar, this is what now. Check it, you are going to get the x is equal to 0.62 meters, you are going to get it. Means if I make the boring for a length of 0.62 meters, the change in length of this bar is equal to, 1.2 times the change in length of this bar now. Okay, Chinmay, okay, 0.624 in the option is given as 0.62. Wherever required, cut down the calculations now. Some students first they will find out the change in length of this now. They will substitute the load is given, length is given, diameter is given, E is given. They will do all these numerical calculations now. Some student definitely we are going to do like this now. They will vote now. Substitute the load is given, length is given, diameter is given, E is given. They will substitute, they will find out that value. So many times I mentioned getting the answer is not a criterion. Getting the correct answer within a less time. So try to go for a vote now. Wherever required, try to cut down the calculations. Good, Mr. Banu Pratap. Whenever I mention at a point means you have to go for the, whenever it mention at a point maximum tensile, maximum compressive, maximum shear. If you ask at point Q, what is the axial stress? What is the bending stress? At point Q, what is the axial stress? What is the bending stress? And what is the torsional shear stress? Then you have to go for the P by A, M by Z, or sigma B max into, so there you have to use this equation now. But whenever simply is asked about now, maximum tensile, maximum compressive, maximum shear stress at a point means you have to go for the principal stress calculations. And whenever a axial and bending stress is there, directly can add that now. Whenever a bending and axial load is there, directly can add it like this. Then how to decide it now? For objective point of view, this method you can use it now. Whatever I am giving now, objective point of view, ask only principal stress. Most of the question they are asking the principal stress. So this is a method should be used only if you ask the principal stress, not plain locations. If you ask only principal stresses, when axial load, bendment and twistment are acting, or nothing but what if you ask maximum tensile, maximum compressive, maximum shear stress in the member. To determine or not at a point in a member is asked now. If you ask in a member, when axial load, shear force, twisting are acting. But if you ask at a point, what happens? Sometimes bending stress 0, torsional 0. But if you ask in a member, simultaneously, what the directly now? Directly sigma x equal to sigma a plus sigma b max. But how to decide the plus or minus? Suppose the axial stress is positive, then you go for plus. If axial stress negative, you go for the negative. What is the meaning of vice versa? Use negative sign. Use negative sign when axial stress compressive nature. How do you know axial stress is a tensile or compressive? Eccentric axial tensile load. It is a tensile load. Eccentric axial tensile load equal to one axial tensile load. Eccentric axial load equal to one axial compressive load. Suppose if the question is given as eccentric axial tensile load, so I have to go for the sigma A plus sigma B max. If eccentric axial compressive load is given, it is equal to one axial compressive load. Then I have to use the minus sigma A and minus sigma B. Vice versa means use negative sign when axial stress compressive nature. Means default I am assuming the cross section of the x face. Here what the meaning of x in a polar axis? Axial and bending stress are always in the direction of the polar axis. Axial and bending stress are in the direction of, yesterday whatever the method I have given, that is the actual method. Taking a point, you have to draw the stresses and you have to take a small element, cube everything. But this method is valid only when objective examination, if you ask directly principal stress and maximum shear stress are maximum tensile, maximum compressive, maximum shear stress in a member when axial load, bending moment, shear force and twist moment are acting simultaneously. But sometimes what a shear force 0. Sometimes bending moment is 0. Bending moment is 0 means this is 0. Similarly, then directly sigma y is 0. Tau xy is equal to can remove this now, otherwise some confusion will be there. Only use this method now. Axial load, bending moment and twist moment are acting. Axial load, bending moment and twist moment are acting. So directly this will be tau t max. But when shear force also going to be there, so chance of mistakes are going to be there, that we are going to discuss. So far you are not studied the all the stress you have studied. Axial stress you have studied, bending stress you have studied, torsional shear. Only one stress you have not studied, the shear stress, that you are not yet studied. Shear stress variation you are not studied. Axial stress variation is studied. Bending stress variation is studied. Torsional shear stress is studied. But you are not studied the direct shear stress variation. This one will become the directly what the other way you can get it this now. Sigma 1 plus sigma 2 equal to sigma x because sigma y is 0. So if you have calculated this value, suppose this 100 I am getting, this is 120 I am getting. So directly this will be about a minus 20. Because sigma x plus sigma y equal to sigma 1 plus sigma 2. So directly sigma 2 equal to sigma x minus sigma 1 means maximum compressive stress is equal to what now? Sigma 2. Sorry. So only one is sufficient now. This is not required now. Either you calculate maximum tensile or maximum compressive. One now. Other one, you need not do this calculation. Other one, you need not do the calculation. Directly you can get the what now? Here sigma y is 0. If you ask directly only maximum tensile stress, you can go for this now. If you ask maximum compressive stress directly, you can use this now. But if you ask both now, either you calculate maximum tensile or maximum compressive. Other one, you can get it what now? Sigma 1 plus sigma 2 equal to sigma x. This case what somebody knows, sir, how do you know the principal stress are unlike? Because of this case what the more circle is intersect the y-axis. This case you already studied, the more circle will intersect the y-axis. So slightly change it also here. You need not call the what because suppose this is a negative. So sigma x you are going to get a negative. So this will become, don't call this as a maximum tensile stress, only call the sigma 1. After calculation you can decide it now. After calculation you can decide it. My conclusion was valid when sigma, this is positive. If this is positive, then this is going to be positive. Suppose this is a negative or positive, depend upon this now. Suppose the axial stress is negative, then you are going to take the minus sigma and minus sigma b max. Then in that case, this value will become as a negative, you will get it now. Now finally, whichever the larger, whichever is going to be a positive. Suppose this is a positive, this is a maximum tensile. If this is a negative, this is a maximum compressive. Suppose this is a negative, is a maximum compressive. If this is a positive, it is going to be what now? Tensile. So this will become as a positive when this is a positive. When sigma x is a positive, this will be a positive. If sigma x is negative, this will be a negative. But sigma x is positive or negative depend upon what now? Axial load. If the axial load is a positive, then this is what the sigma a plus sigma b max. If the axial load is a negative, minus sigma a and minus sigma b max will be there now. So after calculation, whichever the positive, this will be, one will be a positive value, one will be a negative, will get it. Obviously one will be a positive, one will be a negative, will get it now. Then you can find out the maximum shear stress. Maximum shear stress, sigma 1 minus sigma 2 by 2. But instead of this one, suppose if you ask directly in the question, if you ask only maximum shear stress, in this case these two are required or not required, directly what you can do it now. Because when the principal stress are unlike in nature, principal stress are unlike in nature, in plane and absolute both are same. So in plane and absolute both, in plane tau max is given by radius of the Mohr circle. So if you ask directly maximum shear stress, you can go for this now. So like this, so many questions are going to be there. You can use this method now if you want to save your time now, without drawing the state of stress. Where axial stress is tensile, where bending stress is positive, where bending stress is negative. So without all this thing, directly can use it now. So slight correction here. Always this you are getting a positive only. Whether sigma x positive or negative, whether sigma x positive or negative, this you are getting positive only. So whatever I written initial only is correct now. Whether sigma x is positive or negative, because of what now? Even though this is a negative, but this value you are going to get what now? This value you are going to get more than sigma x. Then this you are going to get a positive value, you will get it. So you can tell it as what now? So this is all not required. Because this I am writing the first time, so that students are getting a confusion. Therefore directly this you can call it as what now? Maximum tensile stress. This is check it also, whether sigma x is positive or negative. Even though this value is negative, sigma x is negative, these are negative, but this value will be what now? More than this sigma x you are going to get it now. More than sigma x you are going to get it now. That's why this will be about now. Is a maximum tensile stress, and this is maximum compressive stress. This will be a maximum tensile, this is a maximum compressive. But out of these two, which one is the sigma 1 and sigma 2? Which one is the sigma 1 and sigma 2? The maximum tensile, this is the maximum compressive. But which one is the sigma 1 and which one is the sigma 2? If this value is greater than this now, if this value, first value is greater than this now, this will be a sigma 1. Suppose this value is greater than this now, then this will be a sigma 1. Whichever the larger, out of these two, whichever the larger, that is the sigma 1. Whichever the larger, that is the sigma 1. Whichever the smaller, that is the sigma 2. Major and minor principal stress. If you ask major principal stress, larger of these two. Smaller of but this can be called as what now? Maximum principal stress. Maximum principal stress means this will be the answer, and this will be the minimum principal stress. Maximum and minimum means what you have to take it mathematically. So always mathematically this is what more now. Mathematically this is what larger now. So this will be called as what we cannot tell the major and minor, but this will be a directly what the maximum principal stress, this is the minimum principal stress. But if you ask the major and minor principal stress, so we cannot decide it now. So this is You can use it this now. So slightly wording you change it, maximum tensile, maximum compressive, maximum shear stress at a critical point in a member. At a critical point in a member. In place of the member, try to write down what a critical point. So these are all the calculate the principal stress. Where you are going to calculate the principal stresses now at the critical point. To determine the principal stress and the maximum shear stress are maximum tensile, maximum compressive, maximum shear stress at a critical point in a member. At a critical point in a member. Default always the principal stress are calculated at a critical point. Once I am mentioning this will become the maximum principal stress is the minimum principal stress. But if clearly mentioned what? Major and minor. Major and minor, we cannot. This value is larger or this value is larger, we don't know. This value is more than this now. Value I'm talking, this value will be more than this now when sigma x is positive. Sigma x is positive. Suppose sigma x is negative, this value will be more. If sigma x is negative, this value is more. Then at that time, this will become as a sigma 1. When sigma x is positive, maximum tensile stress greater than maximum compressive stress. When sigma x is negative, maximum compressive stress is greater than the maximum tensile stress. That is when axial load is going to be what? A positive. Check, my dear friend, Mr. Manas. Whatever you written, what now? You have sent us some query now. Now you can check it now. This is only first time I written in the batch. So that's why some modification was done it now. So whenever you are trying anything for first time, because this is the first time I written, that's why so far you can see it now. Never I modified the board now. Whatever I written, never I modified because so many times I written now. This is the first time I written because somebody is getting a doubts now. So to save your time, objective examination. So since I written the first time, so some modification was done it now. But yesterday, whatever the method I used it, that is what a compulsory when now. If you ask the plain look, that is a general method. That is a general method. But this is to save your time. But this is valid when now. When most of the time this only you are going to get it now. Axial load yesterday workbook 2 questions are based upon this going to be there now. Axial load, bendiment and twistment are going to be there now. Mostly you are going to come across these questions only. Suppose axial load is 0. If axial load is 0, what happens now? This will become 0. Yesterday I had done a bendiment and twistment case now. Bendiment and twistment case. If axial load 0, directly you are going to get the sigma x equal to sigma b max and tau x equal to tau max. That only you are taken now. So what the sigma b max? 32 m by per d cube. What the tau x y? 16 t by per d cube. Now yesterday whatever written, that also you can check it now. But yesterday what I mentioned, what sometimes they are asking at a point. This is what now? For generally for design, we are interested in the critical point. These are all what now? At a critical point. Sometimes they are asking an arbitrary point. In question number 41 is not asked the critical point. When an axial load, shear, twistment and bendment is acting, which one are the critical point? Either top or bottom will be there. But in the question is asked at a point Q. Then in that case, this method cannot be used. As yesterday, that method what? That question you have to use the whatever I discussed now. So this is only valid at a critical point. But sometimes in the examination, they are asking some arbitrary point. There, yesterday, whatever, that is the actual method, any question you can use it now. But whatever I written, this is only some of the questions in objective examination, they are asking this now. Only to save the time, you can do it now. Some students may ask now, sir, yesterday should have discussed, but with this one, you cannot do all the questions now. It's only valid what now? To determine the principal stress, maximum shear stress, maximum tensile, maximum compressive, maximum shear stress at a critical point in a member. Critical point in a member. Some arbitrary point is given. Suppose shear force also there now. So there we cannot use it now. So in this case, what now? Which one is the critical point now? Top is the critical point. Therefore, whatever I written, they're all valid at the top. If you go for this one, then you have to decide the where axial stress is positive, where bending stress is positive. You have to do it. But if you use that method directly, can do it now. Whatever I written, this valid at the top here. Which one are the critical point here now? So directly can vote now. These are the critical points. So whatever I written, they're all valid at this point. Now this is what now? Which type of load? Eccentric axial compressive load. So whatever I written there, this is equal to only load, one compressive load. This is what now? One tensile load, one bending couple and one twisting moment. But here one compressive load, one bending moment and one twisting moment. So in this case, which one are the critical point? Which one are the critical point? This is a critical point. So whatever I written, they're all valid at this critical point. Yesterday, what you studied, always be, whenever the what now? Eccentric axial load is there. where the resultant stress maximum at the points nearer to point of application of load. Which surface nearer? No, right side. These are the critical points. But if you use that method, directly can do it. No, directly can do it. Otherwise, you have to do the what? No, first it is equal to compressive load. Then you have to see the what? The bending stress, what? Where the tensile, where the compressive. That all you have to do it now. So if you ask directly, can do like this. Now, whatever I have given, they're all valid here now. So here, what the sigma x now? Minus sigma a and minus sigma b max. Here, what the sigma x now? Sigma a plus sigma b max. In this case, maximum tensile stress is more than the maximum compressive. In this case, maximum compressive stress is more than the maximum tensile. If you want, you can try it and what with whatever I have given, and you can use the general method. You can also try it now. Whenever eccentric axial load, what you have said now? Resultant normal stress is maximum at the surface which is near to the load. Load is near to which side? Now, right side. This is a critical surface. So I'm going to give some numerical data. You can check it now. So somebody can try with the actual method, otherwise whatever I have given now. So what the advantage? Directly can do it what now? This P is equal to how many loads? Now one axial compressive load and one bending moment. Then you have to see the actual method. What you have to see the what now? Bending moment direction. Whether going in the left side or right side, is a positive or negative. But yesterday, whatever the method I have given, directly can do like this now. This is the compressive load. Therefore, sigma x equal to minus sigma n minus sigma b, tau xy. This is the axial load, the tensile. Therefore, sigma a plus sigma b max. Now, written a question here now. For the stepped bar as shown in the figure. For the stepped bar as shown in the figure. Stepped bar as shown in the figure. Determine. Number 1. Maximum tensile and compressive loads. Maximum tensile and compressive loads. Maximum tensile and compressive loads acting on the bar. Number 2. Axial loads at different cross sections. Axial loads at different cross sections. Axial loads at different cross sections. Number 3. Maximum axial stress in the bar. Maximum axial stress in the bar. Number 4. maximum tensile and shear stress in the bar. Maximum tensile and maximum shear stress in the bar. And last one, change in length of the bar. 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 So only generally objective examination they are going to give the mostly 3 loads are going to be given, but I have taken for my explanation I have taken the 4 loads I have taken now. For the stepped bar as shown, somebody is asking to repeat it. For the stepped bar as shown in the figure, determine number 1, maximum tensile and compressive load acting on the bar. Maximum tensile and compressive load acting on the bar. Number 2, axial load at different cross sections. Axial loads at different cross sections. Number 3, maximum axial stress in the bar. Number 4, maximum tensile stress and maximum shear stress in the bar. And last one is change in length of the bar. So if you ask some of the students, now here which condition not satisfied now? Yesterday what you have studied 2 examples now. In first example, prismatic is not satisfied. Second case, pure axial load is not satisfied. But here both prismatic and pure axial load is not satisfied. First condition not satisfied, second condition is not satisfied. So it should be taken as how many bars now? Everybody is going to tell 3 bars. It should be taken as 4 bars. Some students are going to tell, sir, only 3 bars, sir. It's a 1, 1, 1 now. With respect to prismatic is the 3 bars. With respect to prismatic and with respect to prismatic is the what? The 3 bars. Here to the prismatic, here to a prismatic, but what now? You should also check the pure axial loading. Now I can check it here to here what now? It is a pure axial load. It is not a pure axial load. Pure axial load is possible until next axial load. Pure axial load is possible until next axial load. So after this now, where the next load is applied here now? So here to here axial load is a constant. Axial load and magnitude and direction are constant until next axial load is applied now. So pure axial load condition is valid until next axial load. So here to here what now? Here to here what now? Single bar. Here to here single diameter is there. But here to here what now? Pure axial load condition is not satisfied. Here to here what now? Prismatic is satisfied. But pure axial load is not satisfied. But here to here pure axial load. Here to here pure axial load. So this should be taken as how many bars now? 2 bars. So overall this should be considered about 4 bars in series now. 4 bars in series. But most of students are what now? Sir, it should be taken as 3 bars. Whenever you want to use the equation, you have to see the what now? First prismatic should be satisfied. Next pure axial load should be satisfied. Same material. With respect to prismatic, it is a 3 bars. This is a 1 prismatic bar. This is a 1 prismatic bar. This is a second prismatic bar. The third one is the third prismatic bar. But in the second prismatic bar, it is not a pure axial load. But this is what now? What about the third bar? Prismatic and pure axial load. After this now, where the next load is applied here now. So here to here axial load and magnitude are constant. And here one reaction will be there. Here to here what now? In between there is no axial load. Axial load is applied here. Here axial load is there now. So it is going to be a pure axial loading now. But here in between what now? One load is applied now. If I am going to remove this load, it should be taken as a 1 bar now. So it should be taken as overall 4 bars now. So first find out the reaction. What should be the reaction now? How to find out the reaction? At fixed support, how many reaction? 3 reaction, horizontal, vertical and moment reaction. But you are getting only horizontal reaction, no vertical reaction, because whenever you want to get a vertical reaction, there should be a constant point load should be there. Since there is no constant point load, vertical reaction is 0. When a member is what to fix it here now, whenever you provide a fixed support, so to get a vertical reaction, at least one constant point load is required now. So since there is no constant point load, vertical reaction 0. And to get a moment reaction, at least one constant point load or one constant moment is required. Since there is no constant point load, no constant moment, both vertical and moment reactions are 0. Both vertical and moment reactions are 0. Only horizontal reaction. What is the net axial load? What is the net axial load? What is the sum of all this load now? Towards right side, how much you are getting now? Towards right side, 8P. Left side is 8P. Towards right side is 4P. Net load is what now? 4P towards left side. So reaction should be towards right side. Now check it now. It is the equilibrium or not now. After keeping the reaction, check it is the equilibrium condition or not. Towards left side 8P, towards right side also 8P. It is the equilibrium now. when a member is supported at one extreme end by a fixed support, when a member is supported at one extreme end by a fixed support, horizontal reaction equal to minus of sigma h in place of sigma minus of sigma h vertical reaction is equal to net concentrated point load net axial load on that bar. Net means summation of all this now. Next, moment reaction. Moment reaction. M means what? The moment reaction. M means the moment reaction. What is the meaning of minus sign now? Opposite direction. If I am getting sigma h is towards left side, then reaction should be towards right side. If I am getting sigma h is 10 kilonewton towards right side, then horizontal reaction will be 10 kilonewton towards left side. So minus means opposite to this direction now. If I am getting the sigma v 10 kilonewton downward, then vertical reaction should be 10 kilonewton upward. And if I am getting the sum of the couples and moments, I am getting 10 kilonewton meter clockwise, then reaction should be 10 kilonewton meter anti-clockwise should be there. Minus means opposite to this now. Direction of reactions is opposite to the it's just like about a cantilever type. When your support is provided one end, there is about a cantilever you are going to call it now. Cantilever beam means generally what now? If a constant point loads are there, beam means what are loaded by transfer shear loads. But here there is no transfer shear, therefore it is called as a bar now. I made as a member now. Member. Sometimes if the transfer shear loads are there, it is called as a beam you are going to call it now. When a member is supported at one end, one extreme end by fixed support, directly you can get it now. Suppose the question is like this. Calculation of reactions are very important. Calculation of reactions are very important. If the reactions are incorrect, total problem is incorrect. Most of students are going to neglect the calculation of reaction. They are not focused on the calculation of reactions. Now in this question directly what the answer now? What the reactions now? What the sum of the horizontal force or net axial load? How many axial loads are there? 2. So net axial load how much is now? 2p towards left side, p towards right side, 3p towards net is what? 2p towards left side. What the sigma v? W upward. Then what about the net moment now? Net moment where you have to calculate now, fixed support you calculate, net moment you calculate at the fixed support, if I am calling as A. Net moment, what the meaning of sigma m? Sigma m means what? Net moments and couples. Here how many moments are there now? Number of moments equal to what you have said? Number of constant point loads. Number of moments are the number of constant. How many constant point? 1 and 2. 2 moments and 1 couple is there. If it is going to take the sigma means only moments now. You have to take that only I written net moments and the couples. Net moments and the couples at fixed support now. So here 2 moments. Due to this one moment, due to 1 moment. 1 couple is there. So what the net moment? 2W into L anti-clockwise. Is a clockwise and this is a clockwise. So what the net moment? Now this used to be done it now directly. You cannot tell it now. This you can directly tell, but better do this calculation. What the net moment now? Anti-clockwise I am taking negative 2W into L. Anti-clockwise negative. Next W into 2L. Next WL. So what this value I am getting now? I am getting a positive. Positive means which one you have taken positive now? Anti-clockwise you have taken negative, clockwise a positive, means this is going to be a clockwise. Now you can give the directly reactions. So what should be the horizontal reaction? Horizontal reaction, net load is what? 2P towards left side. Therefore reaction should be towards right side. So directly what you have to put it, horizontal reaction 2P towards right side. What the vertical reaction? W downward. And what the moment reaction? What the moment reaction now? This is a clockwise. So it should be anti-clockwise. Anti-clockwise. So now we can keep the reactions here now. If it is going to do the horizontal and vertical reaction correctly only, they are going to make a mistake. Only moment reaction they are going to make a mistake now. So now directly at A, directly this will become the axial load at this cross section. What you have studied now? At extreme end directly, axial load will become the. So what the axial load at A? 2P compressive. What the shear force at A? W negative. Directly this constant point load will become the shear force. And directly this couple will become the bending moment. So at A, what the shear force? Now minus W. Axial load how much? Now minus 2P. And bending moment is what? Now minus WL. And what about here now? Suppose this is a B. This is all you have studied now. At B, it is also extreme end. So directly this will become the axial load. And what the shear force plus W. And what the bending moment minus WL. Bending moment is minus WL. But here how many loads will be there now? Here you are going to get a 2 axial load, 2 shear force, and 1 bending moment will be there. Here, suppose if I call the C the junction. Due to this 2W, 2 shear force, due to this axial load, 2 axial loads, and 1 bending moment. When you will get a 2 bending moments, when a couple is there, but 1 moment will be there, 1 bending moment will be there. Here, directly axial load is minus 2P, shear force is minus W, bending moment is what? A minus WL. Directly at B, axial load is plus P, axial load is plus P, shear force is plus W. And what the bending moment? Now minus WL. But at C, 2 axial loads, 2 shear force, and 1 bending moment. 1 bending moment will be there. But if here also 1 couple is there, then 2 bending moments will be there. That's all you have studied now. A is on the left side, you have to do the left side sign convention. B is on the right side sign convention. Right hand side downward is what? Now shear force positive. Left hand side upward is a positive. And bending moment left hand side clockwise is positive. Right hand side anti-clockwise is positive. and here 2 axial compressive load, 2 shear force, and 1 bendment will be there. 1 bendment will be there. This is only nothing but which equation now? How we got this now? By using sigma h is equal to 0. This is by using sigma v equal to 0. And this is by using sigma m is equal to 0. Now this is called as what a beam you are going to call. This is a beam is called, but this is called as a bar because of there is no couples and no constant point load. This is called as a bar you are going to call it. But this is going to be what are called as a beam. Beam means loaded by constant point loads and constant moments will be there. Anybody what the axial load at C you have done it now? Here how many axial load? 2. But what the axial load at C means what you have done it now? Neglecting and constraining. Here 2 axial load. First you neglect it. So what the axial load at C? What the axial load at C? Axial load at C, what you are going to get if you neglect it? 2 axial load. If you neglect it, what the value now? Minus 2p. Then if you consider plus 3p. So what the value now? Larger of minus 2p and plus p. So what the value now? Minus 2p. Axial load at C. Axial load at C. Directly. Otherwise you have to take a sections. Section in AC, section in BC. Instead of this one, what you are doing now? Neglected. If you neglect it, how much value you are getting now? Minus 2p. Then your previous value minus 2p plus 3p. So plus p. So it will be what now? Minus 2p. Means when C belongs to AC. When C belongs to AC, what the axial load? Minus 2p. When C belongs to CB, what the axial load? Now P. Then what the shear force here done it now? Neglect this W, no, neglect this constant point, or 2 shear force neglected. If you neglect it, left side I am taking, left side downward is negative. So minus W. Then constrain. By neglecting, how much you got it? Now minus W. That is the previous value plus this value you have to consider now. If we are consider left side, this here taken negative means this is a positive. Minus W plus 2W. So what the larger value now? Plus R minus W. So here how many shear force? Now when C belongs to AC, shear force is minus W. When C belongs to BC, plus W. And what about the bendment? 1 bendment will be there now. 1 bendment. When you are going to get 2 bendments, when couple is there. So how to find out the bendment? Now better to consider left side or right side? The left side. So what the bend? Either left or right, anyone you can take. What the bendment at C? W into L. Left side anti-clockwise negative. W into L is the clockwise. What the bendment at C? 0. Only 1 bendment will be there now. I am taking the left side. Left side, sorry, minus 2WL will be there. W into L, negative. It is also negative. 1 couple. Minus 2WL. So here you have to calculate the axial load 2 times, shear force 2 times, bendment is 1 time. If anybody is getting a doubt, means what now? I will not explain, I will not spend time now. Already explained all this thing now. So by chance we made a mistake in the reactions. If we made a mistake in the reactions, these are all incorrect now. If the reactions are incorrect, about a total problem, they're incorrect now. Axial load depend upon only horizontal reaction. Axial load depend upon only horizontal reaction. Shear force depend upon only vertical reaction. But bendment depend upon how many reaction? Both vertical and moment reaction. What the bendment at C? It depend upon this couple and this vertical reaction also. WL, WL. So which reaction very important now? Axial load depend upon only horizontal reaction. If horizontal reaction incorrect means only axial load is incorrect. And shear force depend upon only vertical reaction. So if we are shear force should be correct, vertical reaction should be correct now. Next, bendment depend upon what now? Bendment depend upon this moment reaction and vertical reaction. So which reaction is affecting both the calculation? Vertical reaction. So if the vertical reaction is incorrect, if vertical reaction incorrect, both shear force and bendment are incorrect. If only moment reaction, only bendment is incorrect. But if vertical reaction incorrect, both shear force and bendment are incorrect. So remember what now? Axial load depend upon only horizontal reaction. That is, if horizontal reaction incorrect means only axial load is incorrect. And shear force depend upon only vertical reaction. Bendment depend upon both vertical and moment reaction. Both vertical and moment reaction. So if the moment reaction incorrect, only if moment reaction is incorrect, only bendment is incorrect. But if vertical reaction incorrect, both shear force and bendment are incorrect. So the calculation of vertical reaction very important now. If vertical reaction, both shear force and bendment are incorrect now. If moment reaction incorrect, only bendment is incorrect. Okay. So now I'll come to this question now. So directly horizontal, how you got the horizontal reaction? What the net axial load now? 8P towards left side, 4P towards what the? Towards left, how much you are getting? 8P. Towards right is what? 4P. So net axial load or sigma H is what? 4P towards left side. Reaction should be towards right side. Now what the next step now? So it should be now here How many sections I have to take it now? 4 sections. It should treated as how many members now? AB the one member, the first member, second member, third member, fourth member now. So if I go for the section method, 4 sections are required. If I go for what should be a first step for any of the question and determination of the load? When you want to get an axial stress and change in length, axial load is required. When you want to find out the bending stress, you need a bendiment is required. When you want to find out the torsional shear stress and angle of twist, you need the twistement is required. Now, so how many ways you can find out the 4 methods now? One is section method, one is ALD, one is free body diagram, other one is going to be shortcut method now. Shortcut method. Here, best method is going to be what now? Either ALD or the shortcut method. Best method is what now? Either ALD or shortcut method. When should I use the shortcut method now? Best method what now? When the shortcut, when the section method should be used it now? When one section is required. Section method the best method when only one section is required. But here how many sections are required now? Everybody is going to tell the 4 sections. Actually you need a 4, but 2 are sufficient. How many sections are required? 1 section for AB, 1 section for BC, 1 section for CD, 1 section for DE. So 4 sections are required actually, but 2 are sufficient. Why? Sections are always required for intermediate bars or intermediate members. Intermediate bars are intermediate members. Intermediate bars are intermediate member. Why? Remember now, axial load on any member, axial load on any member equal to axial load at the non-junction cross section. Axial load acting on any member is equal to axial load at non-junction cross section. Now for AB member, which is the non-junction A, so directly what the axial load in AB, axial load at A, minus 4P. Is a compressive or tensile? Compressive. Next, DE member, which is a non-junction E. So what this load? Tensile. Therefore, axial load in DE equal to plus P. So P1 is known and P4 is known. But what about the BC member? B is also junction, C is also junction. So section is compulsory. CD member, C is also junction, D is also junction. So we need the 4 sections. Somebody is what now? Sir, section method will take the more time now. If you take the 4 sections, it more time now. But here 2 sections are sufficient. So I am doing this question with about now, with all the load I am determining by once again with the 4 methods I am doing now. But I am not doing the free body diagram. I am going to the section method as well as the what now? ALD and shortcut method I am going to use it now. First step is what now? Horizontal reaction. And remember what, whenever you are giving the reaction, don't use plus or minus. For reactions, you should not do the plus or minus. You should indicate the direction. Plus or minus should be used only for axial load, shear force, bendiment and twistment. For reactions, never use the plus or minus. Try to indicate the direction. Reaction should be always indicated by magnitude and direction. So REH is what, a 4P towards right side. Now what the next step now? P1, P2, P3. First method is what now? As per method of section. For AB member which is the non-junction A. AB member which is the non-junction A. So directly what the load at A? 4P compressive. And once again what? This also don't use this minus or plus. Bendment is also plus or minus, don't use it now. Here minus means the compressive. Bendment is positive. For a vertical member, bendment is positive means what? Sagging. Top surfaces gets contracted. Next, what the second member now? Second member. Intermediate member. So section is required. So take a one section. Take a one section. So better take it which side? No, left side. Left side. This is going to be about a tensile. Is a compressive. So 4P. I'm taking the left hand side. 2P minus 4P. So minus 2P. So 2P compressive. Next. Once again, CD the intermediate member. CD the intermediate member. So once again, section is required. Then better take it which side? No, right side. Right side is better. No, right side only two loads. This is what now? Compressive or tensile? Compressive. This is a tensile. So what the value now? Minus 6P. So minus 5P. Then what about the P4? DE member. For DE member, which is the non-junction? E the non-junction. What the load at E? Directly what a P? Positive means a tensile load. So what change you have done it now? Actually you need a 4 sections. In place of the 4 sections, you have taken the 2 sections are sufficient. Sir, I want to take the 4 sections, you can take it now. Sir, I want to waste my time now. You can go for the 4 sections now. If I'm going to tell what now? Take the 2 sections. Sir, why not 4 sections, sir? You can take it. Nothing will be happen now. If you want to waste your time, you take the 4 sections. 2 sections are sufficient. 4 are optional. Why? Load acting. Axial load on any member. Axial load on any member is equal to axial load acting at the non-junction cross section, non-junction. So for AB member, which is the non-junction A, DE member, which is the non-junction E. Hence, section method is compulsory for intermediate bars. Intermediate bars. So that's why I have taken the two sections now. Next. Second method is the what now? Second method is the loading diagram. Always the loading diagram should be drawn below this member only. Draw this member below only. Some students are going to draw the bar in one page. Loading diagram is what now? Below this one, they will do all these calculations. Below the bar, they will do all the calculation. Then by that time, what the one page is come, then they will draw the loading diagram in second page. Always below the loading, below the member, loading diagram should be there. Loading diagram in one page and member is in one page, there is no meaning now. So what should be first step now? Draw the longitudinal axis. I'm starting from the extreme left side. Then you can say algebraic from the left side. Left side, how many axial load? Only one. Is a compressive load. Compressive load is taken negative. But what the direction of this load? Not towards right side. So this should be taken as a negative. This should be taken as a negative. So you have to draw the vertical line. Downward. What the next step you have studied now? Draw a parallel line to the longitudinal axis until next axial load. After A, where the next axial load is there now? B. Now this load is going to be a positive. Towards right side you have taken negative, means towards left side is a positive. This sign convention should be used, already mentioned. I am drawing the diagram from right to left. So this sign convention should be used when ALD is drawn from left to right. So towards right side is negative, means towards left side is a positive. So minus 4p plus 2p, minus 2p. Minus 2p. Then draw a parallel line until next axial load. Now this load is once again negative. Towards right side is negative. Minus 2p, minus 3p, minus 5p. Minus 5p. Then draw a parallel line until next axial load D. Now this load is towards left side. Left side is going to be a positive. Minus 5p plus 6p. Minus 5p plus 6p is what? A plus p. Plus p. Now draw a parallel line. Draw a parallel line. Now it's a once again negative. Plus p minus p, 0. you have to use this sign convention only, plus P minus P. Positive. Somebody is going, sir, is a tensile load, sir, why you are taking negative? After completion of the diagram, you check it now. After completion of the diagram, I am getting a plus P or minus P, plus P only. So when I am drawing the diagram, what now? Because you are taken towards right side of the negative, towards right side of the negative, plus P minus P is 0. Is minus P means what? Is not axial load, is negative now. Somebody is what now? Sir, you are taken negative, sir. Negative means not a compressive load. With respect to this diagram is a negative because towards right side of the negative. Everybody is going to asking now, sir, the tensile load, sir, why you are taking a negative now? Negative means it's not a compressive load. With respect to the diagram, when I am taking the starting from the diagram, right side you are taken negative. The plus P minus P. Then 0, net is 0. Then you check it finally now. I am getting the plus P or minus P, plus P. Tensile load only is going to be there now. After drawing the diagram, you check it, is the tensile load is going to be there now. So this will be the ALD. What the first cross checking now? What the first cross checking now? Whether your diagram is correct or incorrect now. All ALD, SFD, BMD, TMD. Now whatever the conclusions I am going to give it now, they are valid for remaining all SFD, BMD, TMD. First conclusion is what now? Diagram should be closed at both the ends. Any diagram. Why? We are all dealing with the equilibrium condition, static equilibrium. Static equilibrium. If sum of the horizontal force 0 means ALD should be closed. If ALD is closed at both the ends means sigma H is 0. If SFD is closed at both the ends means sum of the vertical force 0. If BMD is closed at both the ends means what now? Sum of the moments are 0. Now that is the first cross checking. And next I am going to introduce the new now. Second cross checking is what now? Number of vertical lines. Number of vertical lines in ALD are equal to number of axial loads acting on the bar. Number of vertical lines in ALD are equal to number of axial load acting on the bar. On this bar, how many axial load acting now? 1, 2, 3, 4, 5. 5. This is also load only. Reaction also load. So how many axial loads are applied on the bar? Now 5 axial loads are applied. So ALD should consist of 5 vertical lines. 5 vertical lines. So number of vertical lines ALD are equal to number of axial load acting on the bar. Now what is the generalization now? What is the generalization of this statement? What is the conclusion now? Number of vertical lines ALD are equal to number of axial load acting on that bar or a member. Now what is the generalization? Number of vertical line SFD. Number of vertical line SFD are equal to number of concentrated point load on the member. If the beam is loaded by 4 concentrated point load, then SFD consists of 4 vertical lines. So number of vertical line SFD should be equal to number of concentrated point loads. If number of constant point loads are 4, so SFD should consist of 4 vertical lines. Next, number of vertical lines BMD equal to number of bending couples, or what does the name of concentrated moments on the beam. Number of vertical lines BMD are equal to number of bending couples or constant moment acting on that member. Now same thing, number of vertical lines in torque diagram equal to number of twisting couples acting on that member. That is a cross check now. Number of vertical lines ALD are equal to number of axial load on the bar. Number of vertical and SFD are equal to number of constant point load on the bar. Number of vertical and BMD are equal to number of bending couples or constant moments on the bar. Next, number of twisting couples. So number of vertical and torque diagram equal to number of twisting couple. Now in the previous example, this example just now you completed now. Like this you are taken now. Now if I go for this question now, how many axial loads are there now? 1, 2, 3. So number of vertical and ALD equal to 3. And how many constant point load now? 1, 2, 3. So number of vertical and SFD is 3. How many couples are there now? Only 2 couple, 2 bending couple. Then vertical lines in BMD equal to 2. And no twisting couple, means there is no vertical line torque diagram. 3 axial load means 3 vertical lines ALD. 3 consonant point load means 3 vertical lines in SFD. 2 couples, 1 couple and 2. 2 couple means 2 vertical lines will be there in BMD. Now, next conclusion. The height of the vertical line ALD equal to magnitude of the applied axial load at that cross section. Height of the vertical line ALD equal to the magnitude of the axial load applied at that cross section. Now, here how much axial load is applied now? 4P. So this height should be equal to 4P. And what the axial load here now? 2P. So this height should be 2P. Now whether your diagram is correct or not, how to cross check it now? What this height now? 3P. Then you go for this now. Therefore there should be a axial load should be 3P should be there now. And here what the height now? 6P. Now is the correct or incorrect? What you have to check now? Go for the loading actual B problem now. How many axial load is there now? 1. What this magnitude? 6P. And here what this height now? This height should be equal to this load. This load is P, means this height should be P. So height of the vertical line ALD is equal to magnitude of the applied axial load at that cross section. Applied axial load at that cross section. 5 axial load means 5 vertical line. But what should be the height of that line now? Height of that vertical line equal to magnitude of the applied axial load at that cross section. Now same thing. What is the generalization now? Height of vertical line SFD equal to magnitude of the constant point load. Height of vertical line SFD equal to magnitude of the constant point load at their cross section. So here how many constant point loads are there? 3. So here A. Now your SFD is correct or incorrect? How to check it now? So at A there is a constant point load there. So you should get a vertical line. What should be the height of the line? W. Here a constant point load is there. What is the magnitude? 2W. Then what is the height of the vertical line? 2W. Here what is the magnitude of W? Then you should get a vertical line of W. So SFD should consist of 3 vertical lines with a height of W, 2W and W. Next. Height of the BMD, height of the vertical line BMD equal to magnitude of the bending couple or constant moment. Height of vertical and BMD. They're all very important now. Sometimes directly questions also going to be there, objective examination now. And they are used to cross check it. Every students are going to ask now, sir, can you cross when I'm taking the offline batches now? In middle batch generally what now? 300 students used to be there now. Offline now. With a more spacious. Nowhere you are going to get that much of classroom now. More spacious with centralized AC. Even students are able to what? 5 or 6 hours, they never what? Very distance is going to be there, very spacious, centralized AC, so much of what? Which classroom is going to be what? Surrounded by speakers are going to be there. Even if somebody sitting at the back side is able to see the board, very lengthy board is going to be there. Now whatever you are seeing this board now, 2 times of this board will be there now. 2 times of this one will be there board, or sometimes 2.5. Therefore whoever is sitting at the corners also, they are able to see it now, because some students are what now? Sir is telling the offline 300 students are going to be there. Otherwise no student what now? Joined. They are very spacious, centralized AC, more comfortable. You sit any corner, they are able to see it now. So the height of the vertical and BMD. Height of the vertical and BMD equal to magnitude of the bending couple or constant moment at that cross section. Next. Same thing what now? Height of the vertical line in torque diagram. Height of the vertical line in torque diagram equal to magnitude of the twisting couple at that cross section. Now here how many bending couples are there? No, 2. So BMD should consist of 2 vertical line. What should be the height of the vertical line? WL. Here there is no vertical line. But here one vertical line. What this magnitude you have taken? WL you have taken. So overall ALD consists of 3 vertical lines with a height of 2P, 3P and P. SFD 3 vertical lines with a height of W, 2W and W. And BMD consists of 2 vertical lines with a height of WL and WL. WL and WL will be there now. But, so I made the 3 conclusions here, made it now. So 2 conclusion, number of vertical, 3, always how to cross check. Some students will ask now during the offline batches now, during the break time. Sir, I drawn the SFD, BMD, can you cross check it now? Can you cross check it now? It is not possible. 200, 300 students, our break is going to be half an hour time. It is not possible for me cross check it now. 1 or 2 students, you can cross check it now. Sir, then how to cross check these conclusions only? Now your ALD is correct or incorrect, how to cross check it now? After drawing, first cross checking is what now? It should be closed at both the ends. Next cross checking is what now? Number of vertical lines. How many axial loads are there now? 5. 5 vertical lines. 1, 2, 3, 4, 5. And here this height should be equal to 4P. And this height should be equal to 2P. And this height equal to 3P. And this height should be equal to 6P. This. So height is equal to magnitude of the applied axial load. In SFD, height is equal to what now? Magnitude of the constant point load. Height of the vertical and BMD is equal to magnitude of the bending couple or constant moment. Height of vertical line in torque diagram equal to magnitude of the twisting couple. Next. Now I can see now. But what is the axial load at B? Here how many loads are there now? 2. It's the junction. Vertical line means what? A P and 5P. This is 4P. This height will give the what now? Applied axial load. It will not give the axial load at B. This height will give the what now? Magnitude of the applied axial load. Magnitude of the applied axial load. But what the axial load at B? Larger of this value. Some students are getting confusion now. This height will give the, clearly see no, this height will give the what now? Magnitude of the applied axial load at B. At B, how much axial load applied? 2P, that's all. But what the axial load at B? Larger of this value. What the axial load at B? Larger of this value. What the larger value? No, minus 4P. So what the axial load at C? What the larger value? No, minus 5P. What the axial load at D? Larger of this value. What the larger value? No, minus 5P. Minus 5P. Here 0 and P. Larger value P. So whenever an axial load is applied at a junction, what you have studied now, whenever you apply axial load, what you are going to get it now? 2 axial load will be there. So axial load at that cross section. If you ask axial load at that cross section, what the axial load at cross section B equal to larger value are taken. The height will not give the axial. Similarly, height of the vertical load line will give the what? Height of the vertical and SFD will not give the shear force. Height of the vertical line will give the magnitude of the constant point load. Shear force means you have to take the larger value, you have to take it. Similarly, height of vertical line BMD will give the magnitude of the bending couple. Every bending couple is not a bending moment, but bending couple becomes a bending moment at the extreme end. Every constant point load is not a shear force. only extreme and constant point load will become a shear force. Now, can you draw the SFD here now? Same concept of ALD. How to draw the SFD here now? How to draw the SFD? I'm starting from the left side. Then use the left hand side sign convention. What the left hand side sign convention? Upward is the positive. Left hand side sign convention, upward is positive. Upward is a positive. Now, but this is a downward. Upward is a positive. Left side, what the sign convention? Upward is a positive. So when I am drawing from left to right, you have to use this now. Left side convention. I am going from left to right. Then use the left hand side convention. Upward is positive. But this load is a downward. It should be a negative. Next, draw a parallel line. When you are drawing the ALD, what you have done it now? We have drawn a parallel line until next axial load. Now you have to draw a parallel line until next constant point load. Next constant point load. Now we consider upward is a positive. So minus W plus 2W. Minus W plus 2W. Then draw a parallel line until next constant point load. Upward is a positive, downward is going to be negative. Plus W minus W, 0. Now SFD is closed at both the ends. SFD is closed at both the ends. Mean what the meaning now? Sum of the vertical for 0. Then how to cross check it now? Number of constant 1, 2, 3. 3 vertical line. What this height now? W. This height should be equal to 2W. W. But this height is giving the what now? Shear force or what? It is not the shear force. This height will give the constant point load. But what the shear force at B? What the shear force at B? Larger of this value. But both are equal. One is a plus W, one is a minus W. That's why what you have written a shear force at B plus R minus W. Suppose this is a 2W, this is a W. Then I have to take the 2W. But here both are equal in magnitude. Then what the shear force now? Plus R minus W. That's why what you have studied now. How this distributed now? When B belongs to AB is distributed as a minus W. When B belongs to BC is distributed as a plus W. So remember what? The height of the vertical line will not give the shear force. Height will give the magnitude of the constant point load. But what the shear force at B means larger value you have to take it. Same thing there what now? Height of the vertical line will give the what now? Magnitude of the applied axial load. In BMD, height of the vertical line will give the bending couple. Bending couple. So shear force at B means larger of this value. Both are equal in magnitude. Both are equal in magnitude. Plus R minus W. Some friend was asking previously. I checked it, but I not responded now. सर आपने गलत किया था सर, आपने मिस्टेक दिया था सर, आपने साइन कन्वेंशन नहीं लिया था सर, shear force at B plus R minus W लिखा था सर. देखो इधर, you have to use the sign convention properly. If you are not thorough with the sign convention, nobody can help you now. So remember what the height of the vertical line in ALD will give the magnitude of the applied axial load at that cross section. SFD height will give the magnitude of the constant point load. BMD, the height will give the magnitude of the bending couple. And height of the vertical and torque diagram will give the magnitude of the twisting couple. So yesterday what I not discussed because this much time, that's why yesterday I completed, but these conclusions I not made it now. But these conclusions are going to be useful. Sometime directly objective question will be there now. Sometime directly the SFD will be given like this now. For a beam SFD is as shown below. For a beam SFD is as shown below. What type of loads acting on the beam? SFD for a beam is as shown below. What you have done it now? From the beam you have drawn the SFD. Sometimes SFD is given in the objective question. Then ask now, what type of loads are for a particular beam SFD is as shown below. determine what loads are acting at ABC. Then how to decide it now? 3 vertical lines. At A, vertical line means constant pointed. What the magnitude? W. At B, vertical line. What the magnitude? 2W. W. Mean beam is loaded by 3 constant point loads. At A, W, B, 2W, and C is going to be W is going to be there now. So this is the second method now. Now I'm going for the I'm not using the free body diagrams. Now, I'm making about now. Suppose by chance a prismatic bar. By chance a prismatic bar. I taken a stepped bar I taken. By chance a prismatic bar. And this is made of mild steel. This is aluminium. This is copper. And this is brass. Now what is the shape of the ALD? This you are drawn like this now. But by chance about the loads are same. Loads are remain same. But only this is a prismatic bar. Prismatic bar. In place of stepped bar is a prismatic bar. But made of different material. Like this now. So what is the difference in this bar and this bar now? It is a non-prismatic bar or stepped bar. This is a prismatic bar. But it is made of same material. But this is made of different material. Young's model is different mean material is. But which one is same in both the bars? Loadings are same. Loadings are same. Then what happens now? ALD will reach same. For this case also ALD will get the same. ALD will same. You can check it what the ALD you are going to get the same. So what is the conclusion now? Shape of loading diagrams, shape of ALD, SFD, BMD, TMD are independent of material and independent of the shape of the cross section and independent of the dimensions. Whether it is a what now? Rectangular bar or a circular bar, or whether if it is a what now? If it is a triangular cross section, whatever may be the here we don't know cross section now. We don't know cross section. What is the conclusion now? Shape of the loading diagram, that is ALD, SFD, BMD, TMD are independent of the material, independent of shape of the cross section, independent of the cross sectional dimensions, independent of the cross sectional dimension. Once again for this case ALD will be the same. One of the student was asking now, sir, recently I appeared an interview for BARC interview, sir. So they mentioned, you have mentioned what now? SFD, BMD are drawn for a beam, sir, but they ask SFD, BMD when a cantilever beam loaded with a what now? Constant point, but one cantilever beam with mild steel, another cantilever beam with a rubber is going to be there. Both are same. Shape of the loading diagrams are independent of the material, independent of the cross-sectional dimension. What the definition of the load here written? Algebraic sum of the load either on the left side or right side, where you are not considering the material, where you are not considering the cross-sectional dimension. This is a very important conclusion now. Shape of the loading diagrams are independent of the material, independent of the cross-sectional dimensions, and independent of the shape of the cross-section. Which one will depend upon the material? Strain and deformation. Strain and deformation are depend upon the material, but stress depend upon cross-sectional dimension. Axial load is what? Load is independent, but stress depend upon what? Load and shape of the cross-section and cross-sectional dimension. But what about the strain now? Strain will depend upon the what now? Load, shape of the cross-section and cross-sectional dimension and material also. Strain and deformation. Strain and deformations are depend upon the load, PL by AE. Depend upon the load, cross-sectional dimension, shape of the cross-section and material. But stress depend upon only load and cross-sectional dimensions. So loading diagrams are independent of the material and independent of the shape of the cross-section and independent of the cross-sectional dimensions. Simple example I am going to give it now. In your study room, you are attending about now class now. There are 3 chairs are provided in your room now. Study room. One wooden chair is there, one metallic chair is there, one fiber chair is there. First 1 hour before the break, for 1.5 hours you are attended on what now? By sitting on a fiber chair. Then next you are sitting on a, next 1 hour you are sitting on a metallic chair. Next 1 hour you are sitting on a wooden chair. In all this case, what happens now? Fiber chair, metallic chair, wooden chair. Materials are different. Dimensions are different. But what the load acting on all the bars same. What the load acting on all the, your weight is constant. 4 hours your weight will not change. Whether you are sitting on a what now? Fiber chair or metallic chair or wooden chair. Load acting on all the chairs same because your weight is same. But that load is does not what now? Load acting on all the chairs is same because your weight is same. But that does not depend upon the what now? Material and cross-sectional dimension. But stress depend upon what now? Your weight as well as what now? Dimensions now. And deformation also depend upon the material. So I am coming to the 4th method. I am not using the free body diagram. Those who want to use it, a free body diagram. But generally I am using only these 3 methods now. 4th method is about a shortcut method. P1. P1 means AB member now. For AB member which is a non-junction. AB member which is a non-junction A. What the load at A? 4P compressive. So which one you have taken negative now? Towards right side you have taken negative. Towards right side you have taken negative. Then how to get the P2 you have written now? P2. P1 plus loaded B. I am going from left to right. For BC member which is on the left side B. So what the previous value now? Minus 4P. What the loaded B? 2P towards right left side. Towards right side negative means towards left side is positive. Next, what the P3? Previous value. Next, CD member. For CD member which is on the left side C. We are going from left to right. Therefore, take the load at on the left side of left side is what a C. So what the load at C? 3P towards right side. Right side means what now? Negative. So minus 2P plus minus 3P. Minus 5P. And what about P4? What the P4? P4 is what now? P3 plus loaded D. What the P3 minus 5P. What the loaded D? 6P towards left side. Towards right side here taken negative. So towards left side is a positive. Somebody can also start from the right side. This is important. I already mentioned this will take the less time now. Out of all this, this will take the less time. But what the advantage of ALD is now? You can cross check your calculations. In ALD and your section method, in this shortcut method and section method, we cannot cross check it now. But in ALD, you can cross check your calculation. How to cross check it now? First cross checking is what now? Diagram should be closed at both the ends. Next cross checking is what now? Number of vertical and ALD equal to number of applied axial loads. Next, height of the vertical line equal to magnitude of the applied axial load. So like that you can cross check it now. But this will take the less time. This will take the less time. Now load is completed. Then what the first question is asked now? What the maximum axial load acting on the bar? What the maximum axial load acting on the bar? What the maximum axial load? You can check it now. 5P. First question answer is what now? That is which load now? P3. Then loaded different cross section, axial loaded different cross section. At A, only one load will be there. At A, only one load is there. What the value now? Minus 4P. What the loaded B? Larger of this value. What the larger of this value now? Minus 4P. What the loaded C? Larger of this value? Minus 5P. Loaded D. What the larger of this value now? Minus 5P. At E, only one value now. P. Sir, if I use this method, how to get it now? If you ask at B, B is the junction of what now? B is coming in AB and BC. If you ask at B, I have to take the larger of these values now. B is coming in AB member, B is coming in BC member. So when B belongs to AB, what the value now? Minus 4P. When B belongs to BC, what the value now? Minus 2P. What the larger of the value now? Minus 4P. Similarly, if you ask at C, C the junction of BC and CD. C is coming in the BC and CD. If you ask at C, what I have to take it now? Larger of these two values I have to take it. Previously, you take the larger of these two values now. Now, if you ask at C, C belongs to BC and CD. Then you have to take the larger of these two values, you have to take it. Same thing if you ask at D. D is coming in the CD and DE. D is coming in the D is coming in the CD and DE. Then larger of these values you have to take it. But in the question is asked what now? Determine axial stress at C. That's all. He didn't ask all this calculation. He asked only axial stress at C. Then which method I have to use it now? If you ask axial stress at C, then use this word neglecting and constraining. These are all required what now? When you ask all this calculation. Suppose in the question, sometime objective question, they will ask what the stress at C. If you ask directly what now? Axial stress at C. Most of students, what they will take it now? 3P by A they will write. What this now? 3P area is what now? So axial stress at C. At C. Then what the load at C? 3P. Area is how much is now? A by 2. But this is the incorrect. Incorrect, because this is what now? Junction. This method should be used at A and E. If you ask at A and E, you can direct, because they are non-junction. But this is a junction. So if you ask at C, what I have to do it now? If you ask now, only directly C, then you neglect it. If you neglect it, what the value now? Instead of taking the section directly, use this method now. As per the question to question, you have to change it now. If you ask directly at C, first neglected. If I take the right side, how much I am getting now? Minus 6p plus p. If you neglected, minus 6p plus p. So what the value now? Minus 5p. I am taking the right side, means I am assuming C belongs to which portion now? So when C belongs to CE portion or CD portion, C belongs to CD portion, neglected. Right side, how many loads? Compressive and tensile. Next, C belongs to BC. How to get it? You studied in a previous value. What the previous value now? Minus 5p. Then you consider this value. This value. Previously you have taken this a negative, is a compressive. Now this is going to be a tensile. This is all you have done it, neglecting and considering. So this method is better when now, if you ask at only one cross section. So finally what the axial load at C? Larger value. Which is the larger value? In minus 5p. So answer will be what? 10p by A. Compressive. But 50% of students, 50% of the students, they will write down 6p by A. So if you ask this calculation, this is better now. First neglect it. I am taking the right side. Now this is what now? Towards C or away from C? Towards C. Minus 6p. And this is what? A plus. So minus 6p plus p. Minus 5p. Means I am taking the right side, means I am at the C belongs to CD. Next, C also belongs to BC. When C belongs to BC, what I have to do it now? Previous value plus loaded now. But this should be taken positive or negative. This here taken negative means this is the positive, the opposite direction now. This here taken negative because compressive load towards C. But this is going away from C. Plus. So finally what the larger value now? Now you can also check it now previous now. You are getting the same thing or not? When C belongs to BC, what the value now? Minus 2p. When C belongs to CD, how much? Now minus 5p. So sometimes this method is also useful now. This at C. So this method should be used what? If you ask at one cross section only. If you ask at one cross section. Same thing if you ask at D. D belongs to DE and CD. Both you have to calculate it now. But here, when C belongs to CD and C belongs to BC, area is same. When C belongs to CD and C belongs to BC, area is same. So that's why I taken directly the maximum load now. When C belongs to CD and C belongs to BC, area is same. So directly stress will depend upon only load. That's why I taken the larger value now. Suppose if you ask at D what happens now? When D belongs to DE, area is 2A. When D belongs to CD, A by 2. Then you have to calculate the stress 2 times once again now. If you ask at D, what the stress at D means, what I have to do, what the axial stress at D. Just like how you have calculated the load, similarly you have to calculate the stress also 2 times you have to calculate. Why now? Because here areas are different. When D belongs to DE, area is 2A. When D belongs to CD, area is A by 2. So if we ask at D, stress also you have to calculate 2 times. But here I done only 1 time. Why now? When C belongs to CD, area is A by 2. C belongs to BC also A by 2. When area same, stress depend upon only axial load. That's why I taken the larger value now. But if you ask at D, you have to calculate the 2 times. When D belongs to DE 1 time, when D belongs to CD 1 time. You have to calculate the 2 times, you have to calculate it now. And what the next question is asked in the question now. This was not asked in this now. This I have not asked, but I added just now. Now. What the next one is asked now? Maximum axial stress. Where the stress is maximum. Axial stress maximum, where load is maximum and area is minimum. Where load is maximum, CD. And where area is minimum, CD. So directly can give it now. Axial stress depend upon load and area. In the question is asked what the maximum axial stress in the bar. Maximum axial stress in the bar. Maximum axial stress in the bar. So sigma equal to P by A. Axial stress maximum means load should be maximum. Area should be minimum. Load is maximum in CD member. Area is also minimum in CD member. Area is also minimum in BC, but load is not maximum. Therefore directly maximum axial stress will be maximum axial stress is in BC member, for CD member. What the P3 value now? Minus 5P. What the area? So it is 10P by A. Megapascals compressive. But the next one is asked now. Maximum tensile stress in the bar. And this is what axial stress means on the cross section only. But what the fourth one is asked now? Maximum tensile stress in the bar. And maximum shear stress in the bar. So which one is the critical portion here now? Which one is the critical portion? CD the critical portion. In the CD portion what now? Stress is maximum. AB, BC, CD, there is no tensile load. The pure axial loading, pure axial loading, pure axial loading. Under pure axial loading, you are getting a uniaxial state of stress. Under pure axial loading, you are getting a uniaxial state of stress. And that axial stress is what a compressive. Then you are getting only compressive. There is no tensile now. Uniaxial tensile will get only tensile, no compressive. But uniaxial compressive only you are getting a compressive. There is no tensile. But DE member what happens now? What the DE member now? Tensile load is there. Axial stress in DE member. That is P by 2A. But what is the maximum shear stress in the bar? Under uniaxial state of stress, what is the maximum shear stress? On the cross section, shear stress 0. In the bar is asked now. In the bar. In the bar means what now? You have to consider all the planes. Under uniaxial state of what is the maximum shear stress now? Half of the maximum axial stress. Already what the maximum axial stress, you got it 10P by A. So what the maximum shear stress means half of this now. Maximum shear stress in the bar. For this question, everybody is going for 0. But you have to take it as what now? On the cross section is 0. But in the bar means you have to consider all the planes. Half of Which one the critical portion CD? What the state of stress here now? Uniaxial state of stress. Now this will be the what now? The cross section of where you are getting axial stress maximum CD portion. So what this line now? Cross section, axial stress perpendicular to cross section. So directly this is about the principal plane. So directly this is sigma 1. Sigma 1 is negative and tau max plane where you are getting now? 45. This will be about now. So these planes are what now? Tau max plane. Under uniaxial state of stress, maximum shear stress is what now? Half of, but everybody is going to write down the 0. When the answer is 0, if you ask on the cross section. But the CD member is in which type of state of stress? CD member is what now? Pure axial loading. CD member is what? A pure axial loading. Pure axial loading, you are going to get a uniaxial state of stress. Uniaxial state of stress. So on this cross section, shear stress 0. But so this much of stress where you are getting on the cross section, that is at an angle of 0 degrees. But this much of stress of what you are getting, theta equal to 45 and 135. Always the maximum shear stress planes are at an angle of 45 and 135 to principal plane. Suppose if I not discuss the principle, suppose if I discuss this topic initially, no. If I directly, if I am going to write down, everybody is going to say, how we got it, they are going to tell it now. But if I ask about if you are not study the principal stress chapter, then everybody is going to write down what a 0 now. So on the cross section is 0. This is a cross section. On the cross section 0. So maximum compressive stress where you are getting on the cross section of CD. But that is about at an angle of theta equal to 0. But maximum shear stress we are getting what? At an angle of 45 and 135. Uniaxial state of stress. Same thing what? What the maximum shear stress in DE bar now? What the maximum shear DE bar? DE bar what the state of stress now? Uniaxial tensile. DE bar is what now? Pure axial tensile load. Pure axial tensile load. In DE bar what the state of stress? Uniaxial tensile. So what the tensiles in the DE bar? P by 2A. So what the maximum shear stress in the DE bar? Maximum shear stress the DE bar is what now? P by 4A. P by 4A. So always you have to the analysis of the critical portion now. So which one the critical portion? CD the critical portion. If you ask the same question now, what is the maximum shear stress in DE? Maximum shear stress DE means what now? DE portion which type of loading? A pure axial loading. Pure axial loading, uniaxial state of stress. Under uniaxial state of stress, you are getting what now? Maximum shear stress will be what now? Half of the maximum tensile stress. If you ask the maximum shear stress in DE portion, answer will be what? A P by 4A. I am giving the what all the possibilities I am giving. That's why I am taking the more time now, so that you can answer any of the question. From this one word, so many objective questions are likely to get it now. They may ask only stress at C, only maximum axial load. What the maximum shear stress on the cross section? Directly 0. On the cross section means directly 0. Whenever you want to get a shear stress on the cross section, there should be a shear force and twistment. Pure axial load means there is no shear force or no twistment. So if you ask on the cross section is 0, but in the question is asked what now? In the bar. But where you have to calculate it now? Where the axial stress maximum? Axial stress maximum in which portion now? CD. And the last one is what? A change in length of the bar. In all the bar, which one is same now? Only material is same. So you can take out the 1 by E as common. What the load in the first bar? Minus 4p. What the length now? L. Area is A. What the load in the second bar? Minus 2p. Length is L by 2. What the area? A by 2. What the load in the third bar? Minus 5p. Length is L by 2. Area is once again A by 2. Fourth one is what now? P. Length is L. Area is 2A. So if I can take out the PL by AE is common. So this is minus 4. This is minus 1 by 2. This is minus 5 by 4. Sorry. This is only minus 5. Probably this is 2. 2. Minus 5. And this is 1 by 2. You are getting a negative. What is the meaning of negative here? Now, contraction. Or what you have to put it now? Towards left side. This much of deformation where you are getting a E. So E will move towards left side or right side? No, left side. Check the simplifications now. Some batches I discuss the first chapter first now. This is all I discuss. At the end, principal stress chapter I discussed. When I am discussing this topic, initially what I discussed, as per the workbook, I had taken what now? I completed this question. Where I not discussed the maximum shear stress. I used to do only just like textbook what now? Axial stress. Because by that time I not discussed the principal stress chapter now. So I cannot explain this now. So I completed only axial stress. Then afterwards I completed the principal stress. In the test series paper they have given this question. Some students have done, they applied the concept. 30% of students have applied the concept now. But some students are what now? Answer 0 sir. Mid is given incorrect answer sir. Mid is the test series galat diya tha sir. गलत आंसर दिया था. It should be 0, sir. But they have given answer is what now? 5P by A, sir. How you are getting? Pure axial loading. Only axial load you have mentioned, sir. There is no shear force, no twistment, sir. So shear stress should be 0, sir. They should not go through the question thoroughly now. He is asking on a cross section, it should be a 0. But he is asking in the bar. In the bar means you have to what now? You have to use the principal stress concept, but they will not use that concept now. Who is regular? Who is focused? Who is what putting the efforts? They are able to understand. Who is just like a spectator? Definitely what now? They will not understand. Some students are what now? Sir, this is the first chapter, sir. You are discussing as well very late, sir. In the exam, what now? It is not a university examination. They will not, what now? These are the question from made in the workbook first chapter. This is a question. Solve it. And this question from made in the workbook 7th chapter, or this question from Timoshenko and Gere 8th chapter. Do this question. It is not a university examination. They are going to ask the question chapter wise, but your subject is completely interrelated. Any chapter can be linked to anything now. That's why in the first day I clearly mentioned subject is completely interrelated. Who is going to be focused, who is going to be putting the efforts, and who is practicing, who is regular, they are going to enjoy the subject. They will not have any doubts. But who is irregular, today attending, tomorrow session they will not attend it, till 11:30 they will attend it. Then afternoon they will not, second session they will not attend now. Is it okay? This constant, check it now. Please don't bother about my calculation. Mostly they may be correct, but I am doing all this calculation on my own without calculator. So please try to verify the numerical calculations and numerical calculations. 99% they are correct. If by chance 1%, I written 21 by 2. By chance, if it is a mistake, it is 11 by 2. If it is 11 by 2, you write down 11 by 2 only. You know what now? Calculation you can do it now. Some students, sir, आपने गलत किया था, sir. So don't focus on my numerical calculation. Focus on my concepts. Focus on my conclusions. That you focus. But the numerical you are more perfect than me now. You are having a calculator. Or you are more perfect. So by chance, if any this incorrect now, you do it as per whatever you are getting. Suppose you are getting 11 by 2. Check it. Suppose I am giving 21 by 2. You are getting 11 by 2. Once again you cross check it. After 2 times also you are getting 11 by 2. Then you put it like that to 11 by 2 only. Don't bother about what now. Sir has given 21 by 2. Yesterday some of the mains batch student now. Sir, you have written 100, sir. I am getting 50. I wasted half an hour time, sir. He is what now? Completed what now? Qualified prelims and is going for a mains. And is asking, sir, आपने 100 दिया था सर आंसर, मुझे 50 आ रहा था. मैंने आप 100 बोल के लिखा था, इसीलिए मैंने आधा घंटा मेरा टाइम वेस्ट हो गया था. And is sending us so many personal messages and is going to calling now. I am about to come to the class 7 o'clock and is going to call now. I am about to what? Coming to the class. And my family members are responded to that call. And sir is what? I went to the class now. कब फोन करना है, सर से बात करना है. And the sir will come in the afternoon 3 o'clock or 3:30. I completed a batch and yesterday I reached my room. I am about to enter into the my resident inside now is going to make a call. Sir, मुझे doubt है sir. I have told him, you will talk to sir. मैंने आपको पर्सनल मैसेज किया था सर, आपने सुबह भी फ़ोन किया था, अभी फ़ोन कर रहा था, आपने बाद में बोल रहे. I mentioned what I left morning. I left at 7 o'clock. I had not had a lunch. Let me finish my lunch. Then afterwards, after half an hour, because once again I am having your class. At that time during the class, you can ask now. Teacher is also human being now. If you are free, what now? Teacher need not be free. And what is the doubt means what of, let me what ask now. What's your doubt? सर आपने आप 100 दिया था सर, मुझे 50 आ रहा था सर. That doubt what now? For that one is making what so many calls, so many messages. And that type of students are going to be there. That's why I'm clearly telling now. I written what now? By chance, if it is about the incorrect, whatever the value you are getting that now. For that one, you need not call the about a teacher and can't to check it now. But just now you discussed that ALD, SFD, BMD, TMD regarding the vertical lines. Is it always vertical line or any modification? The vertical line concept is valid when a member is horizontal. But when a member is vertical, what happens now? ALD, SFD, BMD concept vertical line when member is horizontal. But when a member is vertical, yesterday what now? For a vertical bar under self-weight, what the ALD got in a triangle. Then you are getting a what now? Horizontal line. So all this vertical line concept is used when a member is horizontal. But when a member is vertical, what change you have to make it now? That vertical line should be replaced by horizontal lines. Yesterday I done this question now. Self-weight example. So many axial loads are only one axial load. So now you are getting a vertical line or horizontal line? Horizontal, because member is vertical. Your longitax a horizontal line. Longitax is vertical line. In this case, longitax a horizontal line. That's why ALD, SFD, BMD consists of vertical lines. But here longitax is vertical line. Then ALD, SFD, BMD consists of horizontal lines. So try to remember what that horizontal. In a horizontal member, mostly you are getting a horizontal member. Then in that case, ALD, SFD, BMD, TMD consists of vertical lines and height of vertical line. But same thing, what I have to do it now? If a member is vertical, what change I have to make it now? The vertical line word should be replaced by horizontal line. Vertical line word should be replaced by horizontal line. So in a vertical member, number of horizontal line ALD equal to number of axial load. Then height of that horizontal line equal to magnitude of this now. What the axial load W. So what is the height of this horizontal line W. So simply replace the what now? Vertical line by horizontal lines. When a member is going to be vertical. When a member is horizontal, you should use the word of vertical line. But when member is horizontal, that vertical line will become a horizontal line. So with this question, so many points are discussed it now. So many conclusions you have made it. What the conclusion now? In section method, sections are compulsory for intermediate members. Intermediate member. Extreme member is optional. Extreme member is optional. That is because axial load acting on extreme member is equal to, or axial load any member equal to axial load acting at the non-junction cross section. Hence section method are compulsory for intermediate members. And regarding the ALD, SFD you have studied, vertical line concept you have studied now. Now read one question now. For the stepped bar as shown in the figure. For the stepped bar as shown in the figure. Determine for the stepped bar as shown in the figure, determine maximum value of P, maximum value of P. If permissible stresses in AB, BC and CD are AB, BC, CD are 100 megapascals, 50 megapascals and 150 megapascal respectively. 100, 50 and 150 megapascal respectively. Here ALD consists of 4 horizontal lines. How many axial loads are there now? 1, 2, 3 reaction. First you calculate the reaction. What the reaction now? What the net vertical load? Net vertical load is what? A 4P upward. Net downward load is what now? Net downward load is 3P. So the reaction should be P. So how many axial loads are there now? 4 axial loads are there. Then ALD consists of 4 horizontal lines. What is the height of the horizontal lines? Here 2P, 4P, P and P. Here which method is the better now? Which method is the better now? Section method better. How many sections are required? Only one section. Is the first member, second member, third member. So directly what? I am leaving the some space. Finally I draw the ALD, but ALD is not required here now. What the load in the first member? Load at A. Load in first member equal to load at A. What the load at A? Minus 2P. So BC member only one section is required. And third member, CD member, which is the non-junction? D the non-junction. So directly can give the P, tensile. Only one section is required. So always what? If one section is sufficient, directly the section method is better now. Section method is the best method when one section is required. So wherever the one section is required, better do the section method now. So take a section. So better to consider above or below any one. Here what the definition? Algebraic sum of the load either above or below. I am taking above. This is the tensile, this is the compressive. 4P minus P. Now is asking what now? So what the maximum tensile load mean? 2P. Maximum compressive load is 2P. Now what is asked the question now? Maximum value of P. Maximum value of P. But it's given permissible stress given. Then you can use your strength criterion. You can use your strength criterion. And assume A is equal to A value is required. Assume A is equal to 200 mm square. A is equal to 200 mm square. So by using strength criterion, first member, that is about now. What is the safe condition for AB? Safe condition for AB. So P1 by A1. What the permissible stress given? 100. What the P1 value? Not 2P. Area. A the how much is now? 200. Some students are what? Sir, you are not taking minus 2P. Since the compressive stress means permissible stress also compressive. This is a compressive load means compressive stress, then automatically permissible stress also compressive. Then how to write the permissible stress here now? SYC upon N. If this load is a tensile load, tensile stress means permissible stress at tensile. If this is about a shear, then you take a permissible shear. Some students are about now, sir, you are now taking the minus sign. So this value should be assumed as a compressive now. This permissible stress should be assumed as a compressive because stress induced is going to be compressive. So what is the P value now? What is the meaning of this now? If the AB member should not fail, is the maximum or minimum now? Maximum means if the AB member should not fail, the maximum value for P is what now? 10. Should not go for 10 more than 10. Same thing you do it for DBC now. Safe condition for BC. Why you are in the strength criteria uniaxial state of the pure axial loading is going to give the uniaxial state of stress. So P2 upon A2. So what the permissible stress in BC is given now? 50. P2, what the P2 value now? 2P. Area is A by 2. A by 2 means 100. So what the P value now? Less than or equal to 2.5 kilonewtons. Next, same thing for BCD. What the meaning of this now? If the BC member should not fail, what the maximum value for P? 2.5. Safe condition for CD. So now this should be about this is a tensile stress, means this should be assumed as a tensile stress. Sigma T permissible, SYT upon factor of safety. P3 by A3 is a 150. What the P3 value now? P. Area how much is now? 200. So P value how much is now? $30. So what is the maximum value now? Means if CD should not fail, maximum value for P is 30. BC should not fail, 2.5. So finally, what is the maximum value for P? Smaller of this value or larger of the value? Smaller value you have to take it now. Some students are going to maximum mean they will take the 30. So you have to go for a smaller value. Smaller of how much is now? Sir, in the question is given maximum value means you take a maximum value. If you take the what now? If you go above this one, if I take the 30, what happens now? Only this one will fail, sir, safe. But these two are fail now. This is able to withstand a maximum value of P, how much now? 10. Is only 2.5. If I take a 30, both will fail. If I take a 10, what happens now? BC will fail. If I take this one, what happens now? Both the members are safe. Here, what is the maximum value now? 10. Now, 2.5 less than 10, safe. 2.5 less than 30. You have to take the safe condition now. So if the 2.5, what happens? All the bars are going to be safe. All the bars are safe. But most of students options are given as what now? 30, 2.5. So you have to go, somebody is going to give the 3. If the options are, if it is a MCQ question, options are given 3, 30, if the options are given like this, you have to go for the answer is what? 2. Less than or equal to. Less than or equal to. Suppose 2.5 there, you can take the 2.5. 2.5 is given, you can take the 2.5, but there is no 2.5. So I have to go for below this value now. So answer should be 2.2 kilonewtons. Here take it, because it's about now maximum or minimum value. Maximum value should not go above this value. But most of students, they are taking 3, they are going to take it now. If I take a 3, what happens now? BC will fail. But if I take the 2, all are going to be safe now. That only I mentioned starting you discuss how to take the, always use this less than or equal to. Less than or equal to means this is a maximum value. Greater than or equal to means minimum value. So here always what now? If one section is required, I mean the only one section now. Section method the best now. And somebody want to practice the what now? First you complete the question with a best method now. Here best method is a section method. And here for practice, use the other method. What the other method now? ALD, free body diagram, and the shortcut method. Now here how to draw the ALD, draw the longitude axis. But what the advantage of ALD, you can cross check it now, cross check your calculations. Now I'm starting from the top. I'm starting from the A. I'm starting from the top means you have to consider above loads. Above, how many loads are there? No, 2P. Either compressive or tensile, compressive. So what the sign convention you are using now? Downward is a negative. What is the meaning of this now? When I'm drawing the diagram from top to bottom, all the downward load should be negative, upward load should be a positive. Negative, positive, negative, and negative. So this is what a negative. Negative means what now? X coordinate negative on which side? No, left side. X coordinate negative on left side. Therefore you draw the left side. Then what the next step now? Draw a parallel line until next axial load. Where the next axial load be? Now positive. Minus 2P plus 4P. Minus 2P plus 4P plus 2P. Then draw a parallel line. Now once again downward is going to be what? A negative. Plus 2P minus P. Minus P. Sorry, plus P. Then draw a parallel line. Now once again a negative. P minus P. 0. Now the diagram is closed. Closed means what? A sum of the vertical force 0. Then what the other cross checking now? Number of axial loads are 4. Means ALD should consist of 4 horizontal lines. One horizontal line. What should be the height now? 2P. And this height should be equal to 4P. And this height should be equal to P. What this height now? P. And what this height now? P. So this is the ALD. This sign convention should be used. when yield is drawn from top to bottom. Yield is drawn from A to D, that is the top to bottom. Somebody can use the shortcut method also, you can use it. Now shortcut method also you can use it. Now. This may, when compared, this may take slightly what more, but advantage is what now? We can cross check your calculations, Suppose the question is like this, can anybody give which method the best now? Anybody vote now? For this example, which method the best now? Which method I have to use it? Shall I use the section method or ALD or free body diagram or shortcut method for this question? Anybody got the answer now? For this question, which method the best? Which method I have to use it now? You want to get my answer within a less time. Shall I use the section method or shall I use the ALD or shall I use the free body diagram or shall I use the shortcut method? No method is required. Here no method is required. Sir, why sir? Everybody is going to put, somebody will take the two sections, somebody will the shortcut method, somebody will draw the ALD. Why? Here only two members are there. Directly what the load in BC, load at C, what the load at CP, and you find out the reaction. What is the reaction now? So no method is required. Load in AB equal to load at A. What the load at A? Compressive. What the load in BC? Load at C. Some students are use the section method. Somebody will draw the ALD. So methods are required what? When more than two bars are there. But here only two bars are there. Directly what? Now? AB member which is the non-junction A. BC member which is the non-junction C. So directly what the answer now? Load in AB equal to load at A. What the load at A? Minus P. Load in BC, load at C plus P. So what the change in length of the bar? 0. What the change in length of the bar? 0. In both the member, which one is same? L is same, AE is same. What the load in AB? Minus P. So total change in length of the bar is going to be 0. Already somebody mentioned what now? Sir, section method FBD. Section method. No method is required now. Which concept you have used now? Axial load on any member equal to load at non-junction. For AB member, which is the non-junction? A. BC member, which is the non-junction? What? A C. So try to use the what now? Appropriate now. Somebody use the section method, 2 sections. You will get the correct answer, but you may take 1 minute time, or some calculation mistakes are going to be there now. Somebody will draw the ALD, you will take the 1 minute time. If necessary, go for the calculations. So what the conclusion now? When bar consists of what now? Only 2 bars are there. No method is required. No method, directly can give it now. So these methods, ALD, free body diagram, section method, shortcut method, they're all required when more than 2 bars are there. But when only 2 bars are there, when a bar is treated as a 2 bars in series, no method is required. What do you mention now? Load on any member equal to load at non-junction. Load in BC equal to load at C. Load in AB equal to load at A. Directly answer is going to be there now. So we'll take a break. After break, you are going now. You can complete the remaining questions. Now, after the break, you are going to discuss the important topic is what now? Fixed at both the ends. Fixed at both the ends. So far, what you have studied now? Fixed at one end, free at the other end. In all these questions, you have taken what now? Fixed at one end, free at the other end. Now, fixed at both the ends. That is a statically indeterminate case. That is a very important case now. Statically indeterminate case that we are going to discuss after a break of 20 minutes now. So now you can do any of the questions, you can do it now. So we'll take a break. It is 11:45 as per my watch. 46. We'll start at 12:05. We'll start at 12:05. So thank you one and all. We'll meet at 12:05. If any queries, please try to send it immediately. If you don't have the queries, we'll take a break now. So not received any queries here. So conclusion is going to be what? When only one section is required. In the previous that vertical bar case now, 3 bars are there. One section is sufficient. So then section method the best. When only 2 bars are there, no method is required. But if 4 bars are there, 4 bars are mean what? 2 sections are required. In that case, I am going to use the what now? Either shortcut method or ALD. So you can practice it what now? Take all the questions with all the method, 4 methods, you can try it. Then you can decide the which method that you can implement for the remaining questions. But based upon my experience, I am going to tell it. Section method the best when only one section is sufficient. When more than one section is required. In that case, better to go for the ALD or otherwise shortcut method. So thank you one and all. We'll meet it after 20 minutes now.